Hello, another video where I work through and explain AQA A-level multi-choice questions. If you want to try to answer this question yourself, please pause now. If you got the answer C, well done. If you want to see my explanation, please keep watching. So O is the centre of a negatively charged sphere. K and L are 2 points distance R1 from O, and M and N are 2 points at a distance R2 from O. Because L and K are the same distance from the centre of charge, they lie on a line of equipotential. That means the potential is the same at point L as it is at point K. It means there's no work done moving it between L and K. We can also see that N and K are the same distance from the centre of charge, so they too lie on a line of equipotential. So no work would be done moving a positive or a negative charge between M and N or between L and K. So I could write that very simply. I could write L to K, or back from K to L, the work done is going to be 0, and the same from M to N, or back again, the work done is 0. However, if I have a positive charge and I want to move it from L to N, I will need to do some work because that positive charge will be being attracted towards the negative charge here. So for a positive charge, if I want to move that positive charge from L to N, then yes, I will have to pull that positive charge from L to N, so I'll have to do some work, and I'll call that work plus W, positive work being done. That's exactly the same as if I move it from K to N, the same amount of work. However, if I start off with a positive charge at N, work will be done on it by this negative charge. It will be accelerated from N to L. So if I say, again, still thinking just of the positive charge, move it from L to N, we can say the work done is negative work. And again, from M to K, negative work. Let's think now what's going to happen if I have a negative charge and I want to move it from L to N. Negative charge, if I want to move it from L to N, the negative charge is going to be repelled by this positively charged sphere here. So moving it from L to N, I won't have to do any work myself. Work will be done on it by this negatively charged sphere. And that's again exactly the same as if I move it from K to M. But now if I take my negatively charged sphere and negatively charged particle and I want to move it from N to L, I will have to push this negatively charged particle because it's being repelled by the negative sphere here. So I'll have to do positive work. So if I want to move it from N to L, there will be positive work, and that's going to be exactly the same if I move it from M to K, also positive work. So let's look at these options now. Which statements are true? The work done moving an electron, so a negative charge from N to K, is the same as that done moving an electron from K to L. Well, if I move my negative charge from M to K, I will need to do positive work. And if I move it from K to L, no work needs to be done because that's on the lines of equipotential. So that's not true. The work done moving a positron from K to N, so a positively charged from K to M, well, that's positive work, is the same as moving an electron from K to M. So negative, an electron, negative, moving it from K to M. No, that's negative work, so that's not true either. No work is done moving an electron from M to N. Yes, no work is done. That's a line of equipotential. No work is done moving any charged object along a line of equipotential. No work is done moving a positron from L to N. So there we go, moving it from L to N, positron, positively charged. Yes, positive work is done, so that's not true. Therefore, the answer was D. I hope you found this video useful. Please subscribe, please watch more in the series, and please recommend these to your friends. Thank you.